All right, this is our pre-test for chapter 5, very similar to how the test is going to end up. Number 1, what is the measure of angle 8 if we know the measure of angle 4 is 50? Now justify as well. So we know angle 4, they say it's 50, and now find angle 8. To me, those look the same. They're both acute, so I know angle 8 is also 50. If they look the same, they probably are. And I can justify by using a vocabulary word. So let's see. If I look at the relation between these parallel lines, do you notice one's inside the parallel lines and one's outside? But they're both in the same position, right? This one is at the bottom right of the one blue line, and this one is at the bottom right of the other blue line. Okay, if we see that, we can see they're in the same position, and that's called corresponding. We need to justify. That's what that means. Point to that so you remember for your test. We need to justify. Number 2 doesn't ask us to justify. So all we need to do is find angle 6. What is the measure of angle 6 if we know angle 2 is 130? This problem has nothing to do with problem 1 other than we're using the same picture. So it does not have anything to do with the fact that angle 4 is 50. Okay, pretend it's a whole new question. All right, we're just using the same picture, that's all. So angle 2 is this big angle here. It's 130 degrees. What is angle 6? Is it the same as angle 2? No, angle 6 is acute. So if they're not the same, the only other option is that they add to 180. So 130 plus angle 6, I'm going to call it x to make it easier for me, plus x equals 180 degrees. They add up to 180. All right, to solve for x, we're going to subtract 130. So x will therefore be 50, or angle 6 is 50 degrees. It doesn't ask me to justify, so I don't need to give a reason for this one, but if it does ask you to justify, do it. In the figure to the right, what is the measure of angle 3 if the measure of angle 7 is 60 degrees? This one we are justifying. Here's the angle 3. We know angle 7 here is 60. What's the relationship between those two? Are they the same? And what is the word that we used? Yes, they're both the same. They're both acute. So angle 3 is 60 degrees. And justify, I'm going to point down here to give a reason. We need a vocabulary word. They are alternate exterior. Okay, they're both outside the parallel lines. All right, number 4, a triangle has angles measuring 15 degrees and 45 degrees. What is the measure of the third angle? Draw yourself a picture if you need to. One angle's 15 degrees, one angle's 45 degrees. I never draw to scale, so don't mind my drawing. And we don't know this one. We'll call it x. When we don't know it, we call it x. We know that all the angles in a triangle add to 180 degrees. So start adding those angles. 15 plus 45 plus x. If you want to ask me, does it matter what order you add them in? No, it does not. You could add x first. You could add 45 first. It doesn't matter. What matters is that they're all on the left side, and then that equals 180. To solve for x, we add up 15 and 45, which gives me 60. Combining our like terms. If you want to draw your line, you can here. And to get rid of the 60, to get x by itself, we're going to subtract 60 from both sides. Okay, that leaves me with x equaling 120 degrees. So the third angle in that triangle is 120 degrees. Number 5, what's the value of x in the triangle at the right? Okay, the exterior angle equals the sum of these two angles. If you want to do it that way, go ahead. I'm going to do it my other way just to help people understand. All right, if I know two angles, 1, 2, inside a triangle, I can find this third angle here by subtracting the two that I know from 180. So let's add up 130 plus 37. We know how to do this part. This is 167. Okay, that's these two angles added together. So the third angle is just 180 minus the 167, which will give us, let's see, 13. So this little angle inside is 13 degrees. Let me erase it. It looks better. This is 13 inside here, not x. X is the one outside. So this outside angle plus this inside angle form this straight line, and you know what a straight line is? 180 degrees. So if you know part of it, you can just subtract it from the 180. And that will give me my 167 degrees for x. Okay. And yes, there's another way to do that for those people that know it. We have one leg of a right triangle. It is 3.2 centimeters long. The length of the second leg is 5.7 centimeters. What's the hypotenuse? What's the length of the hypotenuse? Of course, this is the hypotenuse. It's the longest side. That's our C when we use our Pythagorean theorem, which is a squared plus b squared equals c squared, used to find a missing side of a triangle, side of a triangle. It doesn't matter which one you call A and B, as long as it's one of those two. I'm going to start with the smallest one, 3.2 squared plus 5.7 squared will equal c squared. All right, and 3.2 squared, that's 3.2 times 3.2, is 10.24. 5.7 squared gives me 32.49, which will equal c squared. Add these up. This gives me 42.73. And I can find c now by taking the square root of both sides. So the square root of 42.73 and the square root of c squared. Well, the square root of c squared is just c, and the square root of 42.73, when rounded to the nearest tenths place, is 6.5. And just so everybody can see how I got that, just in case, 42.73 square root. This is 6.5368, blah, blah, blah. So we are rounding to the tenths place. We look at the next one. Since it's a 3, it tells me I need to stay at a 5. Okay, if this number were 5 or bigger, it would round up to 6.6. But since it's a 3, it stays 6.5. All right, let's do that with number 7 on the back. Turn it over. We have to find a missing side again. When we find missing sides, we use Pythagorean theorem. This time I know the hypotenuse. It's the one across from the right angle. So I know the biggest side. So in my a squared plus b squared equals c squared, I know either a or b, and I know c. I'm going to call it a here. So let's call the 6 my a. We don't know b, and we know c. All right, so we're solving for b this time. We get 6 squared is 36. Oops. Ooh, my board's off. Okay, we got 36 is our 6 squared. We don't know b. And 34 squared is 1,156. All right, to get b by itself, if you want to draw your line, you can. We need to get rid of this 36 first. Do it to the other side as well. That gets b squared by itself. 1156 minus 36 is 1120. And now to get b by itself, I need to square root it. If I square root one side, I have to square root the other side. So b is the square root of 1120. Let's do that one together too. So 1120, the square root, I'm going to write it over here, 33.4664, blah, blah, blah. Okay, we're rounding to the nearest tenths is what it said in the directions. So here's the tenths place. We're looking at the hundredths place to tell me if I stay a 4 or I go up to a 5. Since this is bigger than 5 or bigger we call it, then this is going to go up 1. So instead of 33.4, it's 33.5. And this one has units. What do we got for units here? Inches. 33.5 inches. If another one had units and I missed it, I apologize. Okay, what is the distance between the points A and B? Round to the nearest tenth if necessary. You can use the distance formula, or I'm just going to do it right on the graph because it gives me a graph. Make a right triangle. It doesn't matter which side of these two lines, these two points you make the right triangle on. It'll work either way. I just know I have a distance of 4 horizontally and a distance of 6 vertically. So since this is my right angle and I don't know my hypotenuse, my formula is going to be this. C is the one I don't know. We'll call 4 the A because I like to call the smaller one A, although it doesn't matter as long as C is the biggest side. All right, 16 here. 4 times 4 is 16. 6 times 6 is 36. Add these up. 16 and 36 is 52. And now to get C by itself, we're going to need to square root both sides. All right, the square root of 52, I'll do that one out just in case to make sure, to help people with rounding here. 7.2111, blah. We're rounding to the tenths, so the 1 tells me to stay at 7.2. Okay. And we have the last one. Is each a right triangle? Show your work. No work, no credit. So we know that if it's a right triangle, then a squared plus b squared will equal c squared. So we're trying to see, is this true? Which one has to be c? 6, 5, or 4? 6 has to be C. Why? Because it's the biggest one. I don't care which order you put the 4 and the 5 in, but C has to be the biggest number. So I'm going to call A the smallest one, B the next, and C the biggest number. So let's check. Does this work? 4 times 4 is 16. 5 times 5 is 25. 6 times 6 is 36. Do these two add to 36? 16 and 25 gives me 41, which does not equal 36. So if they don't equal, it is not a right triangle. All right, let's try B. Which one's the biggest one? Which one's C? C is this one again. First one again. They're putting them in the opposite order this time. So A squared plus B squared equals C squared. I'm going to say the smallest one is A again. The next one is B. And the biggest is always C. Let's see if both sides are the same. 6 times 6 is 36. 7 times 7 is 49. Is that the same as 64? Well, when I add 36 and 49, I get 85, which is not 64. Therefore, it is not a right triangle. C. Here's the C. These two are the A and B. I'll do it a different way just to show you. You can do, let me write this down first, A squared plus B squared equals C squared. You can do 8 as A, it doesn't matter, as long as the C is this biggest number. Is this true? Let's see, 64 plus 36, does that equal 10 times 10? 64 and 36 gives me 100. 100 does equal 100, so yes, this is a right triangle. And I hope some people already knew that just by looking at those numbers. I know some of you saw it. 10, 8, and 6 are multiples of 3, 4, and 5. If I multiply all three of those numbers by 2, I get my 10, 8, and 6. And that's my 3, 4, 5 right triangle. Again, you don't need to know that because you can show work and find it out yourself. All right, what do we have? A squared plus B squared equals C squared. Hopefully by now you know where the C is. The C is going to be the biggest number, which is 12. And I'll call A the smallest one again. Again, it doesn't matter, A and B. You can mix up those two. 64 plus 100, does that equal 144? This is going to give you 164, which is not equal to 144. So this is, no. The only one that's a right triangle is answer choice C. That's it.